Okay, welcome to the last part of our game development session. Um, in this session, we will work towards implementing um, collisions between asteroids and the ship, which will result in an explosion and the end of the game. So the code that we developed so far is here. We managed to clean it up a little bit last time. Let's see it running again so that we would remember how it works. So currently you notice that it there's no collisions between the ship and the asteroids, and that's very lucky for the ship. Also, because of that, there's no end to the game. We can keep going for as long as we want. So what we want is whenever this kind of collision that you just have seen happens, we want to have an explosion at the site and end the game. All right. I'm going to close here. And again, remember, because we have this timer now that is running, the code is somehow still running in the background. We have to stop it from here. Checking for collisions between asteroids and the ship is very simple, right? So we can go here, right? After the collisions between missiles and asteroids, we can, again, we clean this up, but we're going to write the code in here and clean it up again later. So for every asteroid, right, we check whether it's collided with the ship. And if that's a collision that results in an explosion, that has to be added to the uh, to the set of explosions, right here. So it's going to be a similar loop, right? And also we want to remove the asteroid from the set of Earth asteroids, and we will not want to stop the game immediately. We want to stop the game only after we have allowed the explosion to be fully animated. All right, so in order to have an implementation of this time to um, um, time to end the game, right? We're going to employ the following trick, right? So we're going to have a variable that is going to start with a negative value. So time to end it's going to start with a negative value, and while this value is negative, we allow it. We don't do anything about it. So if time to end is positive, right? We only care when it's positive. We're going to say time to end minus equals 1. We decrease it by 1, right? And if time to end is 0, then we simply return. By returning, we will not be drawing anything, and then the game essentially ends. All right. So when we are about to end the game because the asteroid has been the ship has been destroyed. We're going to initialize this value with something like 25 or maybe 50, right? And then that will allow for the 24 frames of the explosion to take place. All right, it will give it maybe an extra second or so of a static image, after which the game will stop displaying. So that will essentially be the strategy for ending the game. Okay, so before we implement an explosion, let's just see how this works. Right, so let's detect the collision and see how this works. So we're going to say for A in asteroids, right? And we're going to have to check whether the asteroid and the ship are close, right? So we're going to say that the X for ship is, and so X ship and Y ship is equal to ship position. I think we have a ship position somewhere, right? Ship position, which is right here, yes? And then we have a ship radius for the ship's size. So ship position. And then we have X asteroid, Y asteroid. Y asteroid, right? So we want the coordinates of the asteroid, right? Asteroid, if you remember, is a tuple. So if we take the slice of the tuple that only contains the first two positions, we will get that up to 2, right? Then we'll get the X of the asteroid and Y of the asteroid. So now we have if, and we do exactly as before, right? Delta X square plus delta Y square. It has to be less than the sum of the radii square, right? So let's define the distance d to be ship radius plus asteroid radius. Did we call it asteroid radius? Let's go back and find out what do we call it. Yes, asteroid radius here. So, and then we're going to say if. So this is actually minimal distance. Let's call it dmin, right? So if, we're going to have a delta x and a delta y. So let's compute those as well. Delta x is xs minus xa, and delta y is ys minus ya, right? And now if dx times dx plus dy times dy is less than dmin times dmin. Normally, if we were to compute the distance, we would take the square root. We would take the square root of this, because that would be the actual distance between the two elements, and we will check if it's less than dmin. But because square root is actually much more expensive than squaring in terms of compute time, we use this expression, which has exactly the same effect, but it's much faster to compute. So if this is true, it means that they are too close. And then if they are too close, first of all, let's not do anything else but end the game. So time to end equals 25, right? And then we start at 25, and obviously we want to do this only if time to end is not positive anyway, right? So we're going to say if time to end, if the game is ending, we don't want to check for a collision anymore. If time to end is greater than 0, we can do this. It is less than 0, sorry. We can do this. Otherwise, we don't need to do this. Okay, so now we will see that when we have a collision, the game ends. Sorry, this should be square brackets. And time to end needs to be global. And let's get the focus here. And now you can see how the game has ended. All right, perhaps 25 is too small. Perhaps 25 is too small, so perhaps we want a value of something like 50. Sorry. Yeah, run. All right. So something like that. I need to move faster. Unfortunately, I haven't managed to move fast enough. Anyway, you get the idea. So now the game is ending, right? What we also would like is that whenever the game is about to end, we want to have an explosion, right? We also would like to remove the asteroid from if the asteroid explodes. We want to also want to remove the asteroid. Um, so let's see how we do that. So we're going to have new new asteroids is empty. Sorry, deleted asteroids. So collided asteroids is initially empty, right? So we're going to say collided asteroids dot append, and we're going to add our current asteroid. And at the end, we're going to say for am I still online? For A in collided asteroids, all right, if A in asteroids dot remove A. All right, and another thing that we would like is to have an explosion at the site of the ship. All right, so we would like to have an explosion at the site of the ship. So right here we will say that explosions dot append, and what do we add into, let's remember, what do we add for explosions? So check collisions. In check collisions, we append the XY coordinates, and we start with a 0, which is the initial frame, right? And that 0 gets incremented. So we will append the ship's position, which is XS, YS, and a 0 here. All right, so this should be about it. This should be all we have figured out that we would like to have for this game. Focus. Oops. That was way too fast. So another thing that we want to improve, and we're going to do that shortly, is to have the asteroid spawned at some distance away. But let me see if I can manage to. All right, I managed to. Okay, so unfortunately, again, very fast. But the game ends when the asteroid is very close. Right? We can have the bad luck of the asteroid being spawned right on top of the ship, right? Which is a bit unfair, right? So if that happens, uh, I mean that should never happen. We should try to avoid that. So let's see how we can do that. The solution is actually relatively simple. We're going to say that if in the rock spawner, if the position is too close, all right, we're going to try again. So we're going to start, right, instead of adding these numbers, we're going to generate this number separately. So I'm going to say that x is with the times random.random y equals height times. All right, and here I want to replace this by x and y. All right, and then we will do this for as long as this is too close. So while too close, and I'm going to write this. Oops. Sorry, I'm not sure what I'm doing here. Hopefully I haven't changed the code. Right, while too close. And I'm going to replace that with a proper condition. Right, this is what we should do. X equals y. So we try again. Right, so we would emerge from this, right, with x and y that are far enough. Now these x and y, because we're defining them here, they should have an initial value outside of the while loop, right? So we're going to say that x initially is actually right, exactly, right, x and y, they're actually right exactly the ship's position. So we know that we're going to be too close from the very beginning. Ship position. All right. And then what does it mean to be too close? Right? It means that so we have to compute a delta x and a delta y. So we're going to have dx equals x minus ship position 0. dy is going to be x y minus ship position 1. All right, and what would be a safe distance? A safe distance would be maybe something like 200 pixels. Does it make sense? Or maybe 150 pixels, right? So we're going to say, well, dx times dx plus dy times dy is smaller than 150 times 150, right? Then as long as I'm not at a safe distance, keep generating, right? We know for sure that in the first attempt, that's not going to be true. So we're going to go through the loop at least once, all right? But that's fine, right? So then I have to compute this again. right? And I'm going to keep going in this loop for as long as the asteroids are not at a safe distance. So we only go and generate a safe distance asteroid. Now this loop will actually finish very fast, right? Because random numbers are random enough so that the chance of generating a asteroid at a safe distance is actually quite high, right? So now notice how we don't have asteroids very close, right? They will emerge very slowly towards us. And now, as I have collided, the game has ended. All right, there are other aspects that are not so nice. So as the ship keeps moving. Yeah. So we don't want to allow the ship to be moving when um, when it has exploded. It doesn't give the feeling that um, the um, the game has ended. So what we want is actually to stop displaying the ship, right? Um, so we're going to say here, we're drawing missiles, asteroids, draw explosions, check collision, ship position, draw ship, right? So we're going to say that if time to end is less than 0, then draw the ship. Otherwise, don't draw the ship anymore. All right, so and we can make this even a little bit longer. So let's say 100 here. So now it looks a lot better. Yeah, it gives you the feeling that the game has ended. Again, it was a little bit unfair there in the way that the asteroid was very close to the beginning end. Okay, so now it looks a lot better, right? So the ship explodes, and the asteroids keep moving for a few seconds, and then the whole game ends. All right, and this is where we stop. So having done this, we are at a point where we consider the learning part of the game done, right? The further development of the game is going to be part of the um, of the homework. And what would I want you to implement for the homework? Three things, right? One, I would like to have a notion of lives, um, right? So, sorry, first of all, a notion of score, right? The number of asteroids being destroyed gets printed in the corner of the of the window, right? So either left corner or right corner, somewhere you print the score. So that's number one. Two, you have a number of lives, right? You start maybe with 3 lives, and then you get 3 attempts. The asteroid gets destroyed 3 times, and when it gets destroyed the 4th time, you end the game. And then what I would like you to do as well is that when the game ends, a game over message appears in the middle of the screen, right? So you see how the whole image disappears, and then it just stops there. There's no action on the screen, but we don't have an indication, an explicit indication that the game has ended. We would like to add that as well. And that will be homework number 4, which I was telling you at some point that will be based on this game. So at this point, I will go and fill in exactly the specs for homework 4, and you have everything you need to complete all the homeworks. One thing we still should be doing here is clean up the code, right? So we have extracted every part of the rendering and of the game's logic except for the way the keys are handled. We extracted that into separate procedures. So we should do that as well here, right? We will leave the time to end in, but this entire part should be extracted into check ship collision. So we're going to call it check ship collision. We need at least, I don't think we need a canvas. We'll see exactly what arguments we need. And I can dedent by one level. And then I also need to dedent here. Doesn't seem to work. I'm trying to press Shift Tab and that should dedent, but it doesn't work. All right, so even if another level up to here, it should be right. All right, so what's the, let's check the logic again. So we have the collide asteroids initially empty. We go through all the asteroids. If the distance is too small, we set the time to end to 100. So we're going to start with a time to end equals -1 here, right? Actually, time to end is global, so let's make time to end global. Let's just do that. All right. And then we're going to make time to end equals to 100. We have collided asteroids that increases, and we have explosions. So our explosions is global. So we have a global explosions. All right, for A collided, if A in asteroids, so we also have a global asteroids here, and we remove the asteroids, and we don't need any arguments. So we go back here and say check ship collision, right? Was that the name? Check ship collision. And let's check again that everything works properly. Good. It seems to work properly. This is the game. All right, any questions? So this is the link. The link will be posted in the page, the course page as well. All right. Are there any questions? If not, this is the lesson for today. I will update the homework number 4. And next time we're going to be talking about data processing. We're going to look at how we can extract useful information from data, from data published by different organizations. See you next time. Have a good weekend.